In this video, we're going to graph and interpret systems of equations. A system of equation is two or more equations that share variables. When we have systems of equations, we can graph them and see where do they intersect. That's the solution. A system of equation can have one solution, no solution, or infinite solutions. If it has one solution, it's going to be two lines that intersect. If it has no solution, the two lines will be parallel. And if it's infinite solution, the two lines will be the same line. On this first problem, it says that a taxi driver charges $2 per mile plus $2 regardless of how far he drives. Another taxi driver charges $3 per mile and does not have an additional fee. After how many miles will the two drivers make the same amount of money? We're looking to see where these two graphs will intersect. The first thing we need to do is write an equation for how much money each taxi driver will make. Let's call the first one taxi driver A. We can make the total amount of money made Y. Taxi driver A will make $2 per hour. We can write that as 2x. And then an additional $2 regardless of how far he drives, so we can add 2. Now let's write the equation for taxi driver B. Just like with taxi driver A, we want to know how much money taxi driver B will make. So we want Y equals. But taxi driver B is going to make $3 per mile instead of 2. And then taxi driver B will not have an additional fee. So we don't have a number to add. Now that we have our equations made, we can graph both of them and see where they intersect. The x-axis is going to stand for the miles driven, and the y-axis is going to stand for money earned. When we graph equations, we want them to be in slope-intercept format. That's y equals mx plus b, where b is the y-intercept and m is the slope. The y-intercept is where the graph is going to cross the y-axis. So in this case, driver A's is going to cross at point 2. M is the slope, which is rise over run. And we want that to be a fraction, so we need 2 to be written as 2 over 1. That means we're going to rise 2 and run 1. Rise 2 and run 1, rise 2 and run 1. Now we can connect our dots and we have our line for driver A. Let's do the same thing for driver B. Driver B does not have a y-intercept, so we're going to start at 0. We need to write the slope as a fraction, so that's 3 over 1. So driver B's line is going to go up 3 and over 1, up 3 and over 1, up 3 and over 1. We can connect the points, and now we have driver B's line. Where do they intersect? You can see they intersect at 2, 6. So the question asks, after how many miles will the two drivers make the same amount of money? The answer is after 2 miles. After 2 miles, driver B is going to start making more money than driver A. Now pause the video and try this one on your own. Now let's see how you did. This one says that Lou can decorate 1 cookie per minute and already has 2 cookies done. June can decorate 1.5 cookies per minute and has not decorated any yet. After how many minutes will the two have decorated the same amount? Let's start by writing an equation for Lou. We can make the total amount of cookies made Y. Lou can make 1 cookie per minute and already has 2 made. June, on the other hand, can make 1.5 cookies per minute and has not decorated any at all. So now that we have our equations made, we can graph them on the coordinate plane. We can make the x-axis minutes, and we can make the y-axis cookies. Let's start by graphing Lou's line. Lou's y-intercept is 2, and Lou's slope is 1, which can be written as 1 over 1. So we can go up 1, over 1, up 1, over 1. Connect the points, and we have Lou's line. June does not have a y-intercept, so we can start at 0. June's slope is 1.5. We need to make that an improper fraction before we graph it. June's slope is 3 over 2. So we're going to go up 3 and over 2. Up 3 and over 2. We can connect the points, and now we have June's line. Where do the two lines intersect? They intersect at 4, 6. So the question asks, after how many minutes? The answer is after 4 minutes.